Right, hello, and welcome to another Dauntless Development video. This is part 2 in the FPS tutorial series that started 2.5 months ago. Apologies for the delay. So, let's get to it. Now, where we left off, we'd created our player controller, our player movement script, in which we have the functions handled keyboard input, handle mouse input. And we use these to move forward, back, left and right, whilst also turning the player left and right through rotations, and turning the camera, tilting the camera up and down to look up and down. So in its current state, it looks something like this. That's where we left off. So, the first thing we're going to start with today is we're going to just do one thing that I should have done last time that I guess slipped my mind. And that is, if you notice when we run this program, the cursor, or first of all, you kind of start staring at the sky, and the cursor is not stuck to the screen, so it's flying around. And although everything works kind of as you expect it to, it is the cursor is obviously not stuck to the screen, which you would expect it to be. So what we need to do is we just need one line of code inside the start function, and that line goes like this: cursor dot lock state equals lock mode. Sorry, not lock mode. Cursor lock mode dot locked. Now, I'll explain a bit about this. So, cursor is a class that exists inside of Unity. So it's in Unity Engine. And lock state is it's a cursor lock mode. So that's an enum that decides whether the cursor is locked or, well, I'll show you the options. You have locked, confined, or none. So locked means it is stuck to this. Well, you can see on the screen there. Locked locks the cursor to the center of the game window. Confined simply confines it to the game window, so you can still move the cursor around, but you can't move it off the screen. And none means it's not locked at all. Now, by default, it's not locked, which is why we had the cursor flying off the screen. Now, locked is what you want for a first-person shooter, generally, because you don't want to have the cursor flying around the screen. The only time you might want that is when you're going through menus, in which case you might choose confined or none. But we are going to use locked. Now, this also makes the cursor disappear, so that we won't have like the pointer in the middle of the screen. It will simply just take the mouse input whilst locking the cursor to the center. So now with this line, we have the same thing we had before, except now when we look around, the cursor is nowhere to be seen. It's just stuck to the screen and we can't go off. Obviously, if we hit escape, we can then get the cursor back. But if we click back into the window, it will be locked again. Now, if you have a full screen application, then yeah, it will mean that it won't go off the screen. You won't be able to, say if you have multiple monitors, you won't be able to accidentally go over to a different monitor, etc. So yeah, so that was just one little update to where we were last time. So now we're going to be getting started on making our gun. So we are going to make two types of gun. Now, depending on how long this takes, I might split this into two parts. I probably will split it into two parts. So we're going to make a projectile weapon and a raycast weapon. So we're going to make a ray gun that fires lasers and a projectile weapon that fires bullets. Now, you can use the ray gun to make a gun that fires bullets in a game by using some trickery. For example, Counter-Strike uses raycasts for the weapons, not projectiles, as do a lot of competitive short-range games. I believe Rainbow Six Siege does something similar. And as I said, quite a lot of games. Call of Duty, probably any close quarters games will do stuff like that. I believe Battlefield might use projectile physics, but I'm not certain on that. I know Arma uses projectile physics. But yeah, the difference between the two is with a raycast, with a ray gun, your projectile or whatever fires out of your weapon goes in a straight line from one point to another point, or potentially indefinitely in that direction without changing direction. It won't bend, it won't drop. It will just go in that direction, and it will travel to its destination instantly. So it will take just the same amount of time to shoot for the bullet or whatever, for the attack to hit somebody who is 500 meters away as it will somebody who is 200 meters away or 1 meter away. All of them will happen as soon as the ray is sent out, which is like light, so it's basically instant. But obviously, in the computer, it's not. It won't rely on the speed of light. Um, but if you think of it like a laser, it will just instantly damage that enemy. It will. In term when you're using the ray for a weapon, that is. Rays can be used for all sorts of things, but this is one use that we're going to be making use of. So to start with, we're going to need a gun to fire. Now we don't. You don't need a. I don't have a model that I'm going to use. I'm just going to make a primitive object that I'm just going to call a gun. You can get a model from somewhere if you want, but I don't want to try and include lots of things that you've got to then find elsewhere or have different assets you've got to use. I think the point I want to make is that you can do this. If this is about the code, you can do this with anything. You don't need to be a 3D modeler, or you don't need to have access to lots of assets. So I'm going to just make a 3D cube. And I'm going to zero out the coordinates because it started all the way down there for some reason. So I'm just going to zero out all the coordinates and they transform. So now we have a little cube here. So what I'm going to do is I'm just going to shrink it down so that it's no longer as big as the player. So let's just say 0.2, 0.2, 0.2. So which way is Z? So Z is, so the player is actually facing this way. So this, we want it to be longer in the Z, I guess, as it is like, think of it like the barrel of a gun, maybe. And if we look at the camera preview, we can, so actually what I'll do, so you can drag this game view around, by the way, which can be useful if you want to see how things line up like this. So we can drag this, and there we go. We have a little gun. It's obviously, it doesn't look very good, but it serves the purposes of what we're trying to do. So we'll drag this onto the player, so it's a child of the player, just like the. In fact, that's not. I don't think that's quite right. I think we should drag it onto the camera. Because when we look up and down, we'll also want to move the gun up and down. Yeah, so I'm just going to double check that this all works correctly. Yeah, okay, that's good. So now, as we look around, we can point this all over. And if you had an actual model, then this would look a bit better. But I'll just drag this into a bigger screen so you can see it a bit clearer. But yeah, so we have this little gun. And this will obviously go around and we can shoot. I guess at the moment it kind of looks more like a Minecraft arm, but think of it like some kind of mech that's firing projectiles out of its hand. So yeah, so we have our little cube. I'm going to name it gun, and we're going to have to do a little setup for this. Just in the way of we're going to need to make another object. So we're going to right click gun and hit create empty. And we're just going to call this gun end. Or you could call it gun tip or whatever. But the idea is this will be placed at the end of the gun. And this will be where the projectile or the laser will come out of. So whatever we're firing out of this gun, it will come out of the tip of the gun. And this has to be childed to the gun itself. So there we go. We've set up our little gun here. So now we're going to need to make a script for it. Now, just like we did last time, I'm going to just make it inside the scripts folder. So I'm just going to right click, create script, C# script. And here we go. So I'm going to call this, we'll do the raycast gun first. So I'll call this raygun script. Raygun. There we go. So now we have raygun. Now to start with, we're going to set up our variables that we need. So we're going to need a public transform, and this will be gun end. And the reason, and we're going to need this, as I said, to choose where to fire the laser out of. So I'm going to just go on gun. I'm going to attach this script, and then we're going to just drag gun end onto here. So now, whenever we try to access the gun end variable, we'll be accessing the transform of this. So there we go. So now, all we need to do is set up the functions for firing the ray. So I'm going to make a function called shoot ray. So I'll make it a private. In fact, this should be a public function. Yeah, this should be a public function. So public shoot ray. And the reason we're going to have this as a public function, you could have this as a private function if you wanted, but you'd have to set things up. And obviously, I forgot, you will need to return a void because it's a function. So you need a return type. Yeah, so we're going to shoot ray. The reason this is public is because we are going to be using the player movement script to handle all the input. So we're going to take the mouse click here. Now, I know it's called player movement, so this maybe is a bit... I perhaps should have called it player input. But yeah, now it's player movement. So we're going to just handle... we're just going to take the click inside here. So yeah, so what we can do is we could take the click inside here, so we could have our if input dot get key, or get key down, and then I can say key code. Is it actually? I don't think it's. Is it? It's not. Yeah, mouse 0. Yep. So mouse 0. That's I believe that's the left mouse button, and then you could just say shoot ray, and that will work. In fact, we'll just leave that there for now. But if we wanted to access it from the player, we would have to then use we'd have to have this public. But we'll leave it public so that we can shoot it from elsewhere. Now, what we're going to do is we need to set up this raycast. Now, raycasts, as I've described, are basically, they fire a laser, kind of, if you think like a laser pen, from one point to another. Now, you can specify where they start from, and you can specify the distance they travel, etc. There's a lot of different versions of it. But whenever you're doing a raycast, you almost always want to set up first a raycast hit. And I'm going to call this hit. Now, what this does is this is a little variable that once you fire your ray, information about what it hits will be stored inside here. So that means you can access the, say you hit a target, you can then say target.take damage. Yeah. Yeah, so what we'll do is we will say if, and then we're going to say physics.raycast. So we're accessing the physics class, which is inside Unity Engine. And then we're going to say, so we're using raycast, and we're going to start from an origin point. Now you can see that there's 16 different versions of raycast. So yeah, there's a lot. And all of these are valid. But the one we're going to use is we start from an origin point. So this is going to be gun end. And we're going to say dot position because it takes a vector, not a transform. So we're going to take the position that the gun end is at. Then we're going to decide what direction it's going to go in. And that is going to be transform.forward. Because we're going to be shooting in the forward direction. We could say gun end.forward if we wanted to be specific. I guess, yeah, we should probably do that. Gun end.forward, but because the gun end is at the end, is in the same direction, it doesn't matter. But if we had a model that maybe the gun end was in a slightly weird place, this is the best thing to do, I guess. Yeah. So we'll say gun end.forward. Then we'll say out hit. So this means that we're going to be outputting the information of the raycast, what it hits, to be written to that variable. And then we're going to say the max distance. So let's say 500, just for now. So that's about, I think that's 500 meters in Unity, roughly. I don't think there's a specific unit of measure, but I typically say 1 unit is 1 meter. So this will fire the ray. This whole thing will fire the ray, whether it was in the if statement or not. But what we're going to do is here, the reason we're putting in an if is because this raycast returns a bool, which is either true or false. And if it hits something, we're going to perform some logic. Now, before we can set up that logic, we're going to need to make something to hit. So we will quickly go to our game and we'll create a new 3D object. And I'm just going to make a cube. And just as before, I'm going to zero out the coordinates. And I'm going to place it over here. And I'm going to give it a name. I'll just call it shootable target. And we're going to create a new script called shootable target. And this script's going to be incredibly simple. We're just going to have one function in here, and it's just going to be a public function. So public void take damage. And we can then, when we hit this, we will call this function called take damage. Now I'm gonna give it a little health variable, so I'll say int health equals, and we'll just initialize it to 10, let's say. So yeah, we've got 10 health, and take damage. We'll take an input variable of an int, and it will just say DMG for damage, and then all we'll say is health minus equals DMG. So this minus equals, in case you haven't seen it, just means decrease the value on the left by the value on the right. So we're just decreasing health by damage. And since it's going to be simpler to just output this to the console, we'll just say debug.log, and we'll say where is the, hang on, there it is. Took and then oops, DMG damage now at health. So what this is a way, this is just a string, so we're going to just be outputting to the console, and when you put this little $sign in front of a string, you can input variables by using curly braces. So this will output the value of damage, and then so it took, say, 1 damage now at 9 health, for example. Yeah. And obviously we can do some more logic later, but right now this is just to make sure that we know that everything's working. So we have our shootable target. Now, what we can do is we could say there's quite a few ways to check if this thing that we've hit is a target, and that is one thing we do need to check, because if we try to call take damage on something that isn't the shootable target, then we'll get an error because that function won't exist on that target. So yeah, one way we could do it is we could check if it has the right tag. So Unity has a tag system, which allows us to tag an object with a certain keyword. So when I get in here, you can see tag, untagged, and there's a few that exist already, but you can add a tag to this list, and you can add a custom tag. So we could have, say, target, and then we could say, so now we have this tag. Now, once you've added a tag to the list, that doesn't mean you've assigned that tag yet. You still need to go back and then choose it from this list. But then when you go to any other object, you can make it a target. Now, obviously, you only want to tag the right things with those tags. So you can do that, and then you could say if. So what we're doing here, by the way, by putting an if statement inside another if statement, that's called a nested if statement, if you aren't aware. And that just means, yeah, there's just an if statement inside an if statement. So what we're going to do is we're going to say if, if hit dot transform dot tag equals target, and then we could do the logic. So we could say hit dot transform. Actually, do you need to say that? Yes, you do. Transform dot get component. Yeah, get component. And then we'll say shootable target. And then we say dot shoot. Dot shoot. Did I not make that public? I maybe did not make that public. I did make that. Well, it's not called shoot. It's called take damage. Sorry. Yeah. So take damage, and then we'll pass the value, and I guess we'll have the ray gun have a certain damage value as well. So I'll just make a public int, just so we can change it in the editor. In fact, I will do this more correctly. I'll say serialize field. So what this means is you can have a private variable, but you can still change it in the editor. So private int, and I'm going to say damage, and then we will say take damage, and I'll assign this to be a default value of 1. Okay, so this will work so long as we remember to tag our target as target, which is fine, and tags are quite useful. However, if you're wanting to call into a specific script, what's even safer than just using the tag system is to just, instead of checking if the tag is there, you can just do this exact same thing here that you've done here. So I'll just copy this, then I'll just paste over. So I can say if that does not equal null. So what all we're saying there is if, when you try to find the component, and a component, by the way, is anything that you find inside this. So transform is a component, cube mesh is a component. Anything in the inspector is a component. So if it can't find that component, then it's not a target and therefore it won't do anything. But if it can find that component, then it'll just use that to then call take damage, which is far safer, because then even if you forget to tag it, it will still work. And even if you accidentally tag the wrong thing, it won't do the wrong thing. So it's kind of a way of preventing you from making mistakes. So I mean, if you remember to tag everything, that's fine, but this means you don't need to tag it in the first place. Okay, so we've got to actually add the shootable target script to this, and because it's going to be collided with, I'm not sure, actually, yeah, I will just carry on. And yeah, so this should shoot a ray, and we should see it output to the console once we are looking at it. So click, yeah, there we go. So you can see there, took 1 damage, now at 9 health. Took 1 damage, now at 8 health. 7, 6, 5, 4, 3, 2, 1, 0, and so on. We didn't stop it from going any further. So that's what that's doing. Now, it's obviously it's not as clear because obviously you can't physically see the ray. So we can add some graphical effects later on if we want. But the point is that will instantly, no matter where you are. Oops, I'm facing upside down. So even if you are very far away, and this might not quite hit, it's not. We'll try keep. Actually, we might be too far away. Maybe out of range. There we go. We're in range now. So yeah. Now, one thing to note about this raycast that we've done is although it works, it is shooting out the end of the gun and shooting forward in the direction the gun's facing. Now, if you're going for a realistic game, say for example, Escape from Tarkov is an example I can think of off the top of my head, where the bullets do come out the end of the gun. But in a lot of games, the bullets don't come out the end of the gun. The bullets actually come out of the center of the character, which sounds unusual. But the reason for this is it means that no matter what your field of view is, no matter what your screen size is, etc., it doesn't matter if there's a wall in the way. As long as you can see the enemy and you're aiming at the enemy, the bullets will always shoot for the middle of the screen. So that happens in Counter-Strike, for example. It's just a different style. So in that case, we would want to do some calculations to figure out which direction points towards the center of the screen, or maybe even just draw the ray from the character, which might make more sense. But obviously, this is just taken from the kind of the simplest approach, which is just shoot it out the end of the gun. Now this works fine, as you can see, so we can make something take damage. But what you can also do is you can fire projectiles. Now, looking at the time, that will be split into a part 2. But the reason you might use a projectile instead is because they will have travel time. And whereas this ray is instant, the projectile will have travel time. So, you know, say for example, you can shoot ahead of somebody who's running and then hit them if you time it right, if you shoot where they're going to be running into, depending on how quickly or slowly the projectile moves. So projectiles are very useful and are used in a lot of games. However, they are a lot more expensive because they require a lot of physics calculations, which is why you see a lot of games that try to run a bit more lightweight, like Counter-Strike, etc. They don't use projectiles because all the physics calculations, especially when it comes to automatic weapons, where they're firing lots of bullets, that's a lot of stress to put on the game. When a raycast can do the exact same thing, when you're at such a short range, the bullet basically is instantly traveling there anyway. So it all depends on the game design of what you're working on as to whether you want a projectile or a raycast. But we will move on to projectiles next time. So thanks for watching, and I'll see you next time.